giving me feedback, so it sounds best on the recording. Geometric distribution. So with the binomial ones that we did last class with, as in the next class. So today's Tuesday. Next time I see you, you get your quiz. So next class period, barring any unforeseen events, because I got to say that now in the world we live in, the quiz will be on Thursday. All right, so with distributions, if you remember last time with the binomial ones, we learned all this just because Jackson wasn't here. The binomial distribution was talking about pass or fail, one of two outcomes, right? It was either A or B, pass or fail, and you were given a specific set of trials that you were going to be testing for pass and fail. So we're going to have 1, 2, 3, 4, 5, how many ever successes out of trials, and then that was going to be our percentage. With geometric, we're kind of looking at the other side of this exact same scenario. Instead of trying to figure out how many successes we are going to have, we're going to look at just one success only. So the problem we're calculating is one success. The question we're now asking is, how many times do I have to do the trials to get that first success? So now our variable today, as we go through the notes here, X is now going to represent the number of times I have to do the experiment to finally be successful. So we're no longer worried about if we succeed or not. We're now worried about how many times it's going to take to get there. So the first rule here and the third rule here are the exact same. Still two mutually exclusive outcomes for geometric, just like binomial. And the probability of success still remains constant for each trial. So that's not going to change. Those are the exact same rules that we played with when we did the binomial stuff. What is different is rule number 2. We continue geometric distributions until we find a success. And we won't know what that answer will be. So everything will be theoretical and based on probability. All right, so this is the difference now. No longer do you have a set number of trials. That's thrown out the window. So the random variable X is now defined as the number of trials it's going to take until the first success occurs. So these are in your notes, underline, highlight, rainbow sticker, whatever you want, to make sure you don't forget these types of things. So these rules still have to be in play. Again, nice thing is rule number 1, rule number 3, they're pretty much the same. Really, it's just rule number 2 that switches. I'm no longer counting successes or failures. I'm now counting trials. The success is always going to be the first success. And X is going to represent how many times it takes to get there. So what are the possible values for X? Well, with binomial, it started with 0. I can have no successes, 1 success, all the way up to my trials size. With the geometric distributions, it starts with the number 1. Because if I don't even do a trial, because that's what X stands for, then I'm not even doing the experiment. So there's no 0 on this one. So how far can my distribution go? 1 time, 2 times, 3 times, 4 times? I don't know, many times as you want. All I can think of is that scene from The Office when they're playing volleyball and Pam hurts her ankle and Dwight's trying to stall. What is it? 1, 2, wait, 3. He just keeps going. Same idea here, right? So how many times is it going to take to figure out our answer? I don't know, 7, 8, I can keep going to infinity. All right. Obviously, Matthew and the rest of us aren't going to want to sit here and calculate to infinity, so we're going to use some tricks to help us get to that answer. So again, the main difference between your binomial and your geometric properties is that there is not a fixed number of trials in geometric distributions. You're looking at it from the other direction saying, I know I'm going to succeed eventually. How long do I anticipate it might take? Or what are the chances that that first success on any given number between 1 and whatever? Questions in the homework will reflect that. For those of you guys that were working ahead, this might help make a little bit more clear. Okay, so again, all of this is in your notes. Feel free to underline, highlight, whatever, as we're going through this stuff here. Rainbow stickers, smiley faces, things like that. All right, I already talked about this, but just as a reminder, other differences to be aware of between binomial and geometric. Binomial variables, X is going to start with 0 because you can actually have no successes in a binomial distribution. Geometric, you have to start with 1 for your X. And I'm talking about that little table where you have all your X values and the percentages underneath. Then you have to start with 1 with geometric, because unless you do a trial, then you don't have an experiment. And then for binomial, all of the distributions are finite. So it's 0 through how many times you have already predetermined you're going to give it a go, versus geometric, it's 1 until you decide you're done calculating. So infinite. That doesn't mean it turns into a continuous distribution, because you can still count specific numbers of trials. All right, so questions like this, you have to determine when am I doing a binomial versus when am I doing a geometric. So the first question on here says, count the number of boys in a family of 4 children. This one is binomial because there's only a certain amount of values available for X. Either I have 0 boys, 1, 2, 3, or 4. Done. So the reason this is binomial, there are 4 specific trials that I'm going to do. So I know that's a binomial distribution. This is what we did last class. So we could ask this question, and I could ask Matthew, what's the probability that I have 2 boys? Okay, well, we'll figure out what the percentage is. It's B with a 4 as my sample size or trial size, comma, whatever the percentage is for a boy, put it in a calculator, and we're good to go. With geometric, the question then becomes, count the number of children you have until that first son is born. So there's not a limit on how many children I can have here. And so this becomes geometric because it could be the first kid, or it could take it to the second, or to the third, or to the fourth. You ever see really big families? You ever notice a lot of times, not always, but a lot of times, like the first group of them is all one gender, and then the other one's the last ones because they were trying for one of each. So I was lucky I had one of each, 1 and 1, so we're done. But some of those 4 families, I got 6 girls and a son. Oh, there's that son, all right, child number 7. So that's a geometric equation. All right, so that's the difference between how we're going to solve this, because we know the success will eventually happen, but how long do we have to go until we get there? All right, there's some formulas. We'll use the formulas once or twice just so you guys can see how they work. You specifically need to be comfortable with these 2 here for the average and standard deviation. But this one here to actually solve the equation, we'll do it once just to show you how it works, and then this is where the calculator comes in and makes life nice and easy. With the average, it's pretty straightforward. You do 1 divided by your percentage rate. This percentage rate represents your success or whatever you're trying to determine, so that's easy. And then in your notes and on the screen, these look a little different, but they're the same thing. So on the screen, the square root symbol goes all the way over the whole fraction. So I have to put a little 2 exponent above the bottom percentage here. On the notes, the square root only covers the top half of the fraction, so the bottom one is just the letter P. I use the one in the notes. They're both the exact same equation, so use whichever one you want. But it's 1 minus P, so the complement of the success rate divided by the percentage or the success rate, and then you take the square root of just the top one. If you're going to do the square root of the whole thing, then don't forget to square the bottom. All right, I thought it was a typo earlier, and then I went, oh no, I'm an idiot. I didn't see the square root symbol went all the way through the whole fraction. So I do the one that matches in your notes because that's the one you guys get on the formula chart for your tests and quizzes and AP exams and that kind of stuff. But this one's not bad. I think this is like the older version of the same formula. Okay, so let's practice doing these by hand first. I'm gonna get out my trusty whiteboard, AKA paper, and then write down these examples with you guys, show you how the formulas work, show you how to plug things in, and then we'll talk about the steps for the calculator, and then we will turn you guys loose and let you practice doing an example or 2 on your own. And I can say that's it. There's not a lot of nuance or crazy that we have to worry about on this one. All right, so this is going to be a geometric distribution. So I'll show you guys the format of your answers. Just like with binomial, there's a certain thing you want to write down. So we're going to say this is a geometric distribution, and we see that our percentage for this one is 10%. So the probability of a child being left-handed is 10%. So that's the success rate on this particular problem that we're going to focus our efforts on.
Mr. G, we can't see anything.
No, I know. I'm writing it on my piece of paper before I forget because
okay.
I'm half blind. No, I'm just kidding.
All right, my bad. I thought you were writing on the slides or something.
No, you're good. I haven't gotten there yet. But stay on me, Matthias. You know how I can get crazy. So, all right, so we got a geometric distribution at a 10% success rate. So these 2 things will be required when you're writing out your answers, regardless of which method you like, so that I know that Kate is actually doing a geometric distribution. Otherwise, what we learned last time, and this will be a review for you, Jackson, when I come around later, your binomials look like this, and we'd have like the number of trials times the percentage. Now, there is no shorthand like this for geometric. We'll talk about it in a second. So it has to be written out as geometric. There's no capital G, parentheses, whatever. So don't try to create one. It doesn't exist. All right, so the first question says in our notes, example number 1, the probability a child is left-handed is 10%. Bada boom. What is the probability the first left-handed child is the 4th child born? So what that's saying is, what's the probability that my first success happens on the 4th trial? So when you see the word is, that means equal to. So I want to know the probability that X is equal to 4. So there's a couple different ways you can do this by hand. If you follow the formula says to do 1 minus the success rate raised to the power of your X value that you care about minus 1 times the success rate. So if we follow the formula, right, and this is coming from right here on my notes, then 1 minus p is going to be 1 minus 0.9. And then the exponent for this one is going to be 4 minus 1. All right, so that's going to be 3, but I'm just going to put up there where I'm getting it from. Times the actual success rate, which is 0.1. And that's it. So this is the way to do it by hand. So I can go ahead and simplify this. 1 minus 0.9. I don't know why I put 0.9. The final answer is 0.9. Sorry. 1 minus 0.1. It's my third time today, guys. I'm sorry. Let me just reset here. All right, we're good. So 1 minus 0.1, because that's my percent rate, turns into 0.9. I was just working ahead. That's how it goes. And that's going to be raised to the power of 3 times 0.1 there. All right, so let me stop for a second, back up way far away from the side of the destroy it. Does that make sense right there now that it's done correctly? Right. My apologies, because you're learning something new and I'm confusing the heck out of you. So on the calculator, this is easy. Just 0.9 to the third power times 0.1. And there we go. So our final answer for this is 0.0729. 0.0729. So what is this telling us? What is this answer actually meaning besides just being weird 4 decimals? It's saying that the chance that your first left-handed born child at this percentage rate, being the 4th kid that you have, is that percent. Because remember, we're looking for the first success. We don't care about the 2nd, the 3rd, the 8th, whatever. We're looking at the first success. So the chances that the first left-handed kid born to you, if this is the rate of left-handed people in the world, is that chance. Now, kind of think about what's going on behind the scenes here with this formula. What it's saying is you got 4 kids. This is the 4th kid here, which you know is the first lefty. So they had a 0.1 shot of that happening. Your other 3 kids are not lefties. I'm sure it's safe to say in this case they're right-handed. Okay, that's pretty much the only way to do it. But we'll just say not left to be mathematically correct. So what you're doing is you're multiplying your first 3 kids who all happen to be non-lefties times the 1 kid that was a lefty, and there you go. It's the same thing. We've done this before with our other probabilities from December. We're just not concerned with all of the ways to do it because when are we saying the first success happens? Just right here. So I don't have to times this by 4 like I used to do because I'm not worried about it happening on the first, second, or third one. Not on this problem. All right, so I'll show you guys the calculator for this in just a second, but I want to make sure you guys are okay with the notation, the formula, and kind of what's going on behind the scenes. So this question specifically asked the chances that the 4th child is the first lefty. The next one says, what is the probability that the first left-handed child is at most the 4th child? So that looks like this, that x is less than or equal to 4. So with this one, we're happy with it being the first kid, or it being the 2nd kid, or it being the 3rd kid, or it being the 4th kid. So the first success can happen anywhere along the, what if they're ambidextrous? I think that's what my daughter is. So she just changes whichever one to fit her needs. If they're ambidextrous, they would be non-left-handed there. That's what the classification we give them. So that's why I didn't say right-handed specifically. Anyway, so we're happy with it being the first kid's lefty, or 2nd kid, or 3rd kid, or 4th kid. Well, we already know this percentage here, so we don't have to redo that one. That one's going to be just what we got earlier. We just got to figure out these now, and we're good to go. So for this one, the formula, again, is going to be 1 minus the percentage. So that's 1 minus 0.1, which we know is going to be 0.9, and then it's going to be raised to the x minus 1 power. All right, well, in this case, x is what value on the very first one? Well, x would be 1 minus 1, so this is going to be to the 0 power times 0.1 itself. So that's just for this one. So these are all your x values here. For the second one, your x value is 2, so this is going to be 1 minus 0.1, right? It's going to be to the first power because it's 2 minus 1. Okay, so I'm getting that again from this part right here, x minus 1. So 2 minus 1 gives me 1 times, again, the success rate. For the third one, same idea. We got 1 minus 0.1, this time to the second power because 3 minus 1 is 2. Times 0.1, and then we already know the answer here. We're not going to redo it, 0.0729. If you want to know how we did that one, you can go back up here and look. All right, so then you go through and you do all the math. Well, this is just going to cancel out because this is just 1. Anything to the 0 power is 1. So this is just 0.1 plus, here we're going to have 0.9 times 0.1. Here we're going to have 0.9 squared times 0.1, and then here we already have 0.729. All right, so I can figure out these other decimals here real quick. So we got 0.1, 0.9 times 0.1 is 0.09, 0.9 squared times 0.1 is 0.081, and lastly 0.0729. All right, you add all those up and you get your final answer. Everything looks good. And my final answer is 0.3439. So that's the percent chance you have of one. I better make sure my nines look nice, and Lauren's auditing my stuff. This is the percent chance you have of getting a left-handed child within the first 4 kids. Could be first, could be second, could be third, could be fourth. Your first lefty. So what, again, is going on behind this formula? Well, think about it. If I'm looking to stop having kids once I know I've identified a left-handed child, if that kid is the first kid, then that's it. I'm done. I don't have any more kids. So there was my first percentage. If it's going to take 2 kids, then I'm going to have one who wasn't and one who was, which is that formula. Same thing for the third kid. I'm going to have 2 that weren't, 1 that was. And then we already did the last one. So you can see this is scaling up rather fast in a geometric type formation. All right, luckily,
Wait, Mr. G.
by hand every time. So I'm just showing you guys kind of how all this is working behind the scenes. What you got, Matthias?
Wait, so if they're ambidextrous, wouldn't that mean that it's not mutually exclusive?
Yeah, if you want to be tricky on this one, you can say that. I'm doing it as specifically you're left-handed or not.
Okay. I was asking because, like, if we get a question on the
not category.
Oh, what was that?
I said if you're ambidextrous, then we'll put you in the not category. That's why I didn't say left or right-handed.
Oh, okay. I was asking because, like, on a quiz, if we have a question that's like, is this like a geometric distribution, and it's asking about like left-handed or right-handed, would we say yes or no?
It's a good question. So the objective would get you to say yes, because technically we only consider one of the two. However, you're right, ambidextrous is there, so therefore there wouldn't be 2 mutually exclusive events. So what I would do is rephrase the question is left-handed or not.
Okay.
So it's very similar to the question we talked about last time. Remember, we had Republican voters?
Right.
And everybody was like, well, that means the other ones have to be Democrat. It just means not Republican. They can be Green Party, Capitalist Party, you know, anarchists, Antifa, fascist, whatever. They're just not Republican.
Okay.
So start thinking of it like that. It makes our lives a lot easier because we're not really worried about what it isn't. We're just worried about what it is. And in that case, we wanted it to be Republican. In this case, we want it to be left-handed.
Okay.
If that'll help you out, because you're not wrong. I don't want you to think you're wrong. It's just I would not try to ask a question in that format that would lead to confusion. I would say, is it geometric?
Yeah.
And I would say, you know, I'm trying to identify if a kid is left-handed. You would say yes, because either they're left-handed or they're not.
Okay, got it.
It's fair to say that that's the case. Ambidextrous people typically do more with their right than their left. Yes, they can do left, but in general. Good question, though.
All right.
All right, so first one, probability that the 4th child is the first lefty. Number 2, probability that the first lefty happens within the first 4. And then the last one under says, what is the probability that the first left-handed child born is at least the 3rd child? So this one is probability that X is greater than or equal to 3. Now, with this one, we have to be careful about how we want to do this on paper, because anything greater than a number in a geometric has no end. So technically, if I wanted to add up every single possibility, I can't stop. I just got to keep going. So instead of doing it the hard way, we've learned last class that this is the same as saying 1 minus the probability that X is less than or equal to 2, because even though this is weird, there's this many values for X and all of them add up to 1, which is not good for our brain to see that infinity and 1 are kind of the same thing. But if I take away the only 2 things I don't care about, then everything left over has to be my result. So for this one, I'm going to say, okay, this is the same as 1 minus the probability that it's the first kid plus it's the probability it's the second kid. And again, we already figured out these 2 answers from the previous page. So this is the same as 1 minus, what did we get? 0.1 plus, what did I get for the second one? 0.09. So you should get equal to 0.81. So the chance that your first left-handed child comes at the third attempt or higher is 81%. But remember, third attempt or higher means third attempt until you're done having children. So if you're just willing to have that all-star first baseman who plays baseball, that has to be a lefty, and you're not stopping having kids until you have that lefty. There's no limit. Just keep going. I mean, you got an 81% chance it's going to take you at least 3, according to this percentage. Does that kind of make sense what we're looking at? I agree 100%. Your kids are going to be what they're going to be, but you'll run into them more as you get adults. People don't get more manageable and friendly when they get older. They get worse. Sorry. If you think your classmates bother you, just wait till they become adults. Okay. Matthew's like, don't tell me that, Mr. G. I know it's depressing, but it is life. All right, so let's look at the calculator tricks, and then let's turn things over to you guys and call it a day here. So in the calculator, there are 2 functions that'll help us out. So if you want to go back and look at the slides, there's my answers. For the calculator, and Miss Nichols, by the way, if you're looking at the answer keys online, likes to show all the different ways you can still do geometric, because there's a lot of times more than one way. Don't feel like you have to do them all. Just pick one you like and go with it. I'll explain that when we get to the calculator part. All right, so for the calculator, there is a geometric function just like binomial. There's a PDF version and a CDF just like binomial. So for geometric PDF, this means you're looking for a specific value of X. I want to know what the likelihood it happens on the 4th try, or the likelihood it happens on the 15th try, whatever, that specific event. And so you would just use PDF, and then your percentage goes first, and the number of tries that you want to test are going to be your X value here. If it is, there's no N because, again, there's no fixed numbers. And then for CDF, it's the cumulative probability up until that point. So what's the chances it happens at like 4 or below, or 10 and below, or whatever. So you can add up all of those cumulatively. So we don't have to do what we just did on the notes where we had to like write them out, plus this one, plus it'll do it all for you. So it knows the pattern inside the thing. So TI actually did a good job. I think with both of these programs, the geometric and binomial, they save you a tremendous amount of time. Please get comfortable with them. I know a lot of you guys took pre-AP Algebra 2, and those teachers, as wonderful as they are, make you feel guilty as heck using the calculator. They're like, just don't touch it. Don't even look at it, Matthew. Calculators are bad. They're evil. Yeah, so Matthew's got PTSD from touching the calculator because they've scolded him from calculator work, all right? Stats class is different, man. Love this thing. Buy it flowers on Valentine's Day. Take it out to dinner, whatever, because this is your best buddy. Okay? Do not feel guilty about using the calculator in this class. You're not going to impress me by how much you do it on paper. I mean, if that impresses you, go for it, but I'm not going to care. All right, so if you're trying to impress me, use the calculator. All right, so showing work. What do you need to show? The thing that's in bold there, where it says geometric, comma, P equals 0.3, and then your probability statement. I want to find the chance that the 4th attempt is my first success, and then the answer. All right, there is no shorthand for the geometric like there is for binomial. So I don't want to see capital G, parentheses, it doesn't exist. Yeah, I don't know what you're doing. All right, there's no N because there's no set number of trials. And sometimes it is easier to just do the formula that's at the bottom of the slide than it is to do the calculator work. If you're really looking to save yourself 5 extra seconds of life, then you're welcome to do that. I, however, like to do the things over and over again, get really comfortable with them, repeat them. That makes it faster for me. So I always do this method. Even if Kate can prove to me that she can do it 3 seconds faster than doing this math, I still would do this method because I would rather just do it the same way every time, know that I'm getting the right answer and move on. That just, the stress level that I would have would be much lower. So that's just me. You guys do it however you want. I would accept either one of these two. They're both the same. Okay, so let's start with the calculator now. So one more time, I'll write down a piece of paper so we don't forget. We still have the same scenario, so you guys can still check that we're doing this right. It is still geometric. Our chances of getting a lefty are still 10%. All right, we want to know the probability that X is equal to 4. We want to know the probability that X is less than or equal to 4 because that's at most the 4th child. And we want to know the probability that X is greater than or equal to 3, meaning at least the 3rd child. So here we go. Let's do these things. So with the calculator, since this one is an equals, we will use the PDF. So turn it on, clear everything. Second vars, just like it was for the binomial. Told you guys we're going to wear this out. So second button, vars button. Hit the up arrow, boom, and we're right there at geometric. It's at the very bottom of the list. Otherwise, you got to hit the down arrow about 15 times to get there. I want PDF, so hit up arrow one more time. Remember, PDF is the equal sign. All right, this is very easy. Type in your percent, 0.1. What is my X value? 4. Press enter. Ta-da, life is nice. Seriously, guys, use these calculators to your betterment. You have testing quizzes, and people always tell me, Mr. G, that wasn't much time. Well, if you're using the calculator, you should have like 15 minutes to go get a snack, come back and check your answers. So that's why it's built that way. If you're trying to do everything by hand to verify it, then you're working too hard. This is all I would need to see. Geometric, percentage, probability statement, answer. Full credit. Okay, I got there. Just remember, if you're copying a friend, then that friend better be getting the exact same version of your AP exam, which they won't, and you're going to be screwed. So don't do that. Well, Mr. G will give me by class. They will, but that day that AP exam hits you, you're going to get a 1, and you're going to be upset because you spent all this time and money for nothing. All right, probability that X is less than or equal to 4. So second, vars. Now we want CDF because we want the cumulative probability from 4, 3, 2, and 1. So hit that one. Oh, it's the same screen, which means you have to be very careful and watch which one you're doing. They're going to look exactly the same. So my p-value is still 0.1, and my x value is still 4. Press enter a few times. All right, there's really not much difference between these two other than that little letter right there, so watch it. Be very careful which one you're doing. So this is 0.3439. So far, are we good? We got the same answers as before? Yep. Again, remember what these percentages are telling you, because you know an FRQ question is going to come along and say, okay, Matthew, what does this tell you? All right, well, this is telling him that the chance his first left-handed kid at this rate, that's what it's telling. So just make sure you're paying attention. That's all. All right, last one. How do I do greater than, Mr. G? Remember, we talked about the shortcut. It's 1 minus 1 less. All right, so if you need help again, remember, think of it like a number line that keeps going into infinity. I want everything going this way. So if I take away those two, ta-da, I have what I want. Remember, there's no end to the right. So unless you want to do every possible is, you're going to be here forever. So second, vars, this is CDF again, same percent value, put in 2, don't put in 3, put in 2, and then do 1 minus what you didn't want, which is that first 19%, and then you get the same answer we got earlier. Numbers are difficult. There we go. No, you don't have to write this. You have to write this, but you don't have to write this. So if in your brain, Kate, you're like, I got it, then that's fine. I write it under just so you guys know what I'm typing in. But no, this is optional. I just need the actual probability statement and your final answer. All right, we feel good about this? Questions? Zoom people, we good?
Wait, I did this one wrong.
Which one?
You have to subtract the number, right?
Yeah, so your
okay.
0.19 is this here, so you got to subtract it. Yeah. Don't worry, I've done that before many a times, and we'll probably do it again myself. All right, try the next example in the notes. Real estate agent shows a house to prospective buyers. The probability that the house will be sold to a buyer is 35%. What is the probability that the agent will sell the house to the third person she shows it to? So see if you can do that one. If you're feeling like these are easy and you got it, try the average and standard deviation formulas on the next one, and then that is it. So I'll give you guys a couple minutes to try that. I'm going to do attendance really fast, so don't go anywhere. Speaking of attendance, Zoom peeps, please don't forget to do those attendance checks. Some of you guys aren't. And if the house office or somebody emails me and says, hey, was Matthias here on Friday last week? And I'll be like, well, let me go check his attendance check. Oh, he didn't do it, so I guess he was absent. So if you don't want that to happen to you, I'm not saying it does very often, but if you don't want to take that risk, please keep up with the attendance checks. Yes, there's stupid questions like, how are you feeling today? But it's okay. I just want to know that you guys are here. Bless you. And then say Jackson will have plenty of time. As soon as it's done, I can catch up on. I'll give you like a fast version, and if you want more detailed, the video's on the dealy hooch there, the canvas. The canvas. Yes. So you just have to decide if it's equals, less than, or more than, and then solve it accordingly. Oh, you got a further question?
They worded the exact same with the same.
Oh, yeah, but this was without calculator. This was with
Oh,
calculator.
okay.
That's all. Sorry, I thought you were talking about, I thought you were talking about the one we're on. Yeah, they're the exact same questions. So you should get the exact same answers. I was just more or less trying to see if you guys could figure out how to use the calculator. That's all. That is all. Did you fall asleep during that exam? You fall asleep during that exam? No, of course. Just to see if you're paying attention. You guys don't realize the kind of creative ability that's taxing on my brain to come up with examples to begin with. I got to come up with things that are believable, because if it's not, you guys are like, nobody'd ever do that. So then I got to, then from there, I got to pick numbers that'll match our thing. A lot of work. And I can't just copy everything I find online, because then you guys just Google it. So, no, that's not me, Mr. Jenkins. Yeah, I Googled it, so I know you guys did. First thing I did in some of them college classes, is there a quizzes with all the answers? Yes, there is. All right. Okay. Example number, I guess this is 3 with the real estate company. So we know it's geometric, because once she sells the house, that's success. We move on. We don't care how many houses how many times she's gonna sell the same house. She's gonna sell once. So our probability of success is 35% for any buyer. All right, already been predetermined by us. We don't have to figure that out. So what is the probability that the agent will sell the house to the third person she shows it to? So what is the probability that the success happens on number 3? So with that, we can go to the calculator, turn everything on. Second vars, geometric PDF. Our percentage rate is 35. Our X value is 3. We press enter a few times and we get 0.1479. So this is all I need to see when you solve this problem. You got anything else on there? Awesome. You don't have to do it, but this is all I need to see. So that takes care of that. Now for the next 2 questions, or the next question with 2 parts, average and standard deviation. So for an average of these, it's 1 divided by the percentage rate. So for this particular problem, it is 1 divided by 0.35, which gives you like 2.8 something. Yeah, 2.8574. 71. Whew, my numbers are not good. I hurry up and quit this before I mess you guys up. So the reason why we just picked 3 here, because this is the most likely outcome. I wouldn't say most likely, but this is the one we would expect. So if you're a real estate agent or whatever, and you're like, man, I wonder how many times on average it's going to take me to get a success on this one. It's reasonable to assume around 3. So that's why we did ahead and did the percentage. And then we said, okay, there's about a 15% chance of that happening. So she should not be disappointed with the current percentage rates that the first 2 people didn't buy the home, if that is what happens. Now, if she gets like number 15, all right, we're going to do here in a second, the standard deviation, we can start to say, hey, maybe you're not doing something right. 15 people gone through here, somebody should have bought it by now. Okay, because we could do the probability that it's 15 or earlier, and you can see it's probably a really large number. All right, so that's the kind of cool thing you can do if you think that's cool. With these geometric questions, you can see like, okay, I'm on like the 55th try. I still have yet to do whatever I'm trying to do at this success rate. Is that reasonable? Nope. Or yep. And then now you're not like so hard on yourself, or tell yourself to step it up. Standard deviation. I use the one in the notes which says the square root of 1 minus the percentage divided by just a percentage. If you use the one that does the whole square root like this, just don't forget to square the bottom. Both of these are the same thing. So we got 1 minus 0.35, square root of that over 0.35. So this is the same as the square root of 0.65 divided by 0.35. Gotta write it down because I've been screwing up stuff all day. So second square root of 0.65 divided by 0.35. So there's my steps. I got 2.3035. Don't forget to put labels. I always forget. Don't forget. This is people, buyers, something. Give them some sort of meaning. They're not just random numbers. So give or take 2-ish buyers in either direction is reasonable within 1 standard deviation of this thing. So anywhere from 1 to 5 people, she's probably doing fine. But like I say, if you were curious, you're like, okay, what's the chance it's going to take her, the 16th try to get this thing or more? Okay? If you want to be nerdy and see how these things work. Well, this is the same as 1 minus the probability of x is less than or equal to 15. Don't want none of me. So you go in here, and again, this is not in your notes. This is me being, what the heck, why not? So our probability is 35, x value is 15, and it's 1 minus that number. All right. So 15 people have seen the house and haven't bought it yet. She's not doing something right. And she's got a 0.1% chance of that being likely. So you might see a question hint like this in the homework that asks you something like this, like, hey, this is the actual rate. This is what they. Does this seem reasonable? What's going on here? Okay, so you can test any number in here that you want because it can go to infinity. All right, that's it for the notes. You guys got any questions for me? Don't sign off just yet, Zoom, because I want to make sure you guys understand everything else. But any questions on these? We're good, easy enough. I feel like this one's easier. Now do you understand what the question's asking? I know Matthew was like, the wording was terrible. It is, but now do you kind of understand what it's doing? It's not so hard. All right, so what am I doing for the homework? So if you haven't done this already, yes, thank you, King. I did see that and the thing. I signed into Discord last Wednesday or Thursday. I didn't see much going on, but I saw your guys' announcement. So thank you for reminding me. I do appreciate it. I have it on my calendar, not to forget. And you can take as long as you guys want. I just chill. I go home and I just chill from the house. So just like you guys, we're all doing it from at home. All right, so for the homework, we did the bunko activity in class, and including your guys' theoretical version of it. If you haven't done that yet, do so. The discrete worksheet was after the first day's lesson, and then you had 2 binomial worksheets, and then today I'm only adding 1 more page, and that's this geometric worksheet here. Everything from this page before is fair game for the quiz, which is going to be next class. Okay, so this that what I just showed you on the screen is due by tomorrow at midnight. If you've already got most of that done, because it doesn't really take that long if you just sit down and do it. I think I've been doing it a little bit at a time for the last 3 days, and it's like 30 minutes to 45 minutes. Yes, I know how to do this, so it's probably a little faster for me. But in general, it shouldn't take you too much time if you're spreading it out equally. If you're feeling like, this is pretty easy, can I get some more practice, or can I knock some other things out now while things are kind of slow and easy to begin the year? You guys, I believe, got the supplemental packet last class, right? And I'll give you one, Jackson. So the supplemental packet, you could do the first page front and back and the next page after that. If, again, you're looking for some more practice and you want to get these done now so that at the end of the unit, you're not trying to do these when you know your AP US history and government NIM are going to start having more quizzes and tests. They're probably starting off a little bit slower. So if you want to get this knocked out, but you could do the first page, the second page, and then this page here. So you can do the first 3 pages because after that, it's all continuous and we haven't talked about it. So this would give you some extra practice if you're looking for it, because there could be some kind of questions that might look like this on the quiz or test. This is not due, though, as homework on Wednesday. This you got until like the 28th or something, or 26th to do it. But I'm just offering it as a, yes, Emily, it has to write out the whole thing, geometric. Yes. Sorry, we're a pain in the butt on that. Yeah. Okay, so do those homework assignments. Turn them in on the turn-in thing by tomorrow, 11:59 p.m. Quiz on Thursday. We'll do a little bit of continuous notes after the quiz. Continuous, believe it or not, is just as easy as this stuff. If you think this is easy, then you should be good. With continuous, you have to dust off your old geometric area formulas, like area of a triangle, area of a square, area of a trapezoid, that kind of stuff. I'll remind you if you don't remember how to do them, but that's all you guys are doing. All right, Zoom, that's all I got. You guys got your 30 minutes or more to work on this. Have a great rest of your day. If you think of anything else, feel free to pop back onto Zoom, hang out with us if you want. We're just going to be working on homework. But if you got to run, adios. See you later. Went like fly out of here. Went from about 18 users to like 2 with 1 beep. Yeah, well, they all signed off. So it's just us now. There we go. Nobody loves at home learners anymore. It's a good thing Kate